Welcome everybody to the really great Carbon 5 Programming Languages Extravaganza, part 7 or 8. I'm going to be talking about JavaScript today, and I chose JavaScript because I think it has an interesting history. It's a very long and convoluted history. I'm only going to go into a little bit of it. But another thing about JavaScript in relationship to us, to Carbon 5, is that probably more than any other programming language at Carbon 5, pretty much everybody here knows it to some degree. Every engineer, I bet, has programmed in JavaScript. And so what I would like to do, I have this talk, and as I mentioned in Slack, for those who saw, there's some slides for individuals who have interesting fun facts about JavaScript. I would like for this talk in general, if you have a thing that you want to say or ask along the way, if you have if I said something wrong or I said something not quite right enough and you want to jump in, and just raise your virtual or in-person hand and jump in. If you want to actually me, let's do it. Bring it on. I'm interested. Because everybody here knows about JavaScript. So I'm just going to share some of the stuff that I find interesting, and you all should participate in that as well. As I was saying to some people who hadn't, or the people who had joined, but more people have joined, this thing that looks like a sort of level 12 ninja regular expression down here is actually phonetically how you pronounce JavaScript. As I was told by Wikipedia, there's some whole phonetic pronunciation language. I thought this one looked really cool, so I added it here. So in case you didn't know how to pronounce JavaScript, this is it. And that's the talk. Any questions? Okay, I'm talking a little bit about the history of JavaScript because it is definitely interesting. Can everybody can see my screen, right? Okay. All right. There was a time, long time ago, called 1995, and some important things were happening in the world, at least in the United States, is all I looked up. A movie called Forrest Gump was winning Best Picture. Michael Jordan, for those who recognize that gentleman right there, is coming out of retirement for the first time, getting ready to win his 4th, 5th, and 6th basketball championships. And the 55-mile-an-hour speed limit that had, from what I understand, been imposed during a war of some type to like Carter. It was being abolished. And so those of you who want to drive 85 miles an hour as you like zoom through certain states in this country can thank 1995 for that, because it was made available to you. And in addition, there's a little company called Netscape that had just been born a year earlier, and it was trying to change the world. And this company, Netscape, was about to make 2 extremely influential engineering hires. The first one, as I'm sure everybody already knows about, is this fellow right here, who was hired just a year later. But that aside, there was another person who was hired at Netscape in 1995. Was it 95? Yeah. April 3rd, 1995. Mark Andreessen sent a message to Brendan Eich, who is, many of you know, not maybe everybody loves. He has some baggage, but Mark Andreessen said, hey, we're building this thing called the web browser. I want you to come build Scheme inside the web browser. So Brendan showed up. See if I can remember what I was thinking when I was writing these slides. So when he got there, turns out it wasn't exactly Scheme that they wanted him to build. They wanted him to build a programming language inside the Netscape web browser. But at that time, Netscape had a close partnership with Sun. Sun later went on to acquire half of Netscape, the company, and AOL acquired the other half. But Netscape and Sun had a tight relationship, and Sun at the time was busy inventing Java. And they decided that the programming language that they wanted to put inside of the Netscape browser was going to be something that fit within that world of Sun and Netscape and Java. And it was eventually called JavaScript. It was originally called Mocha. It was also called LiveScript for a little while, but that didn't hold. From a branding perspective, they wanted JavaScript. Funnest fact about JavaScript: it was built in 10 days. Functional, not functional, well, yes, functional, but I mean working programming language in production software. Netscape Navigator version 1.1 beta, I believe, was built in 10 days. A number of things that we still deal with today, in a way, were born out of this idea, this fact that the first version of this programming language was built in 10 days, which is, I mean, it's incredible. What else can I say about that? The reason it was built in 10 days is that they needed it to be out in this, for this particular release of the Netscape browser. And the fear was that if it wasn't in this browser within this 10-day period to make it into this release that had already been sort of announced, that Microsoft, arch enemy of Netscape at the time, and building their own browser, which would temporarily completely take over the world, was going to build VBScript into their browser and would win the browser programming language war, and we'd be stuck with VBScript to this day. So 10 days, got it in there. Now, after that, when they started working on Netscape Navigator 1.2, Brendan and a team of people built a new version of JavaScript, and they called it SpiderMonkey. And the version of JavaScript that is in Firefox today is still codenamed SpiderMonkey. And that took several months, sort of like a normal software project. But a number of the decisions that were hatched, thought through, and implemented within 10 days back in 1995 are still with us in JavaScript, because, as I'll talk about a little bit, every attempt to unbackwards compatibilize JavaScript over the past 2.5 decades have completely failed. I mean, we don't even try anymore, because it's there's been so much time and energy wasted trying to build a non-backwards compatible version of JavaScript and get it adopted in places, and it just hasn't worked. There's a fantastic talk and paper. I have links here, and I will share these slides with anybody who wants them. It's called JavaScript: The First 20 Years, and it talks about some of this stuff, some really interesting stuff, and some interesting stuff about Microsoft, some technical things. But as just a little taste of that. So like I said, Netscape Navigator 1.0 came out, and pretty immediately Bill Gates at Microsoft decided that the web was the future of Microsoft's technology. Microsoft at the time was building a sort of America Online-like kind of walled garden-y, connected, Prodigy, for those of you who remember the olden days. When Netscape Navigator came out, they correctly changed course and said, okay, the open web is the way to go. So what we need to do is build a browser. That browser was called Internet Explorer, and Internet Explorer fairly quickly took 94% of the market share. I mean, it literally owned the, I mean, this was years later. So there was a battle between Microsoft and Netscape for the browser and web server, which is the top at the years when I was there. And Microsoft won. As part of that, there was immediately this battle over the scripting engine that was going to go into the browser. Netscape, by releasing JavaScript in version 1.1 of the browser, I believe, kind of won who was going to have the syntax. Microsoft started creating their own version of that called JScript, and if, as many may remember, they also had VBScript in their browser. So they had two options, script lang equals something. Like, why is there a lang equals something? It's always JavaScript. Well, you used to be able to write VBScript there, actually. And JScript, which was Microsoft's, was essentially a port. Like they were reverse engineering it in real time. And there are some funny stories in this paper and whatnot about how in many, and the whole browser was, Internet Explorer was kind of a reverse engineer of Netscape Navigator, because early on Netscape Navigator had the brand. It was the thing, everybody knew about it. Soon after that, Aaron, go ahead.
I was going to ask, like, I don't really even remember the reason why these browser vendors wanted to get their language. What benefit did Microsoft have for trying to get people to use VBScript over JavaScript?
I think it was only before there was a scripting language in the browser. I think both companies realized that was going to happen, and they, at the time, Microsoft's programming environment was Visual Basic. There was no .NET, there was no C#, there was no J#. So that was the language reference that they had. Netscape didn't have anything, but they had the partnership with Sun, so they had Java. So basically they were building a scripting language mirroring whatever other programming language they had closest to them. And so that was Visual Basic versus Java. And it was like a small group of engineers on either side who were doing it. So it was just people, right? It was just like in my own backyard type of stuff. When Netscape got JavaScript in before Microsoft got VBScript in, Microsoft didn't try and push that hard on that. They just said, okay, well, we'll just build JScript, right? Like we'll use that sort of non-specified language, right? It wasn't based on a specification yet. There was no ECMAScript yet, or ECMA, the organization. And I'm sorry, ECMA, the organization existed, but ECMA, I'm forgetting a little bit. Anyway, so that's where the VBScript versus JavaScript thing came. But then Microsoft just jumped on the bandwagon, and then fairly quickly, these two companies, primarily these two companies with some other people, created this organization, this group called TC39, which became like the standards body for JavaScript. And it was just a small group of people. It was primarily Netscape and Microsoft people. And they evolved what became ECMAScript, the specification, together. So it was interesting. There was, like you might expect in many pairs of large organizations, like the organizations that were Netscape and Microsoft were literally bitter enemies, but there was also a lot of collaboration going on amongst individuals. As a side note, the way that Microsoft won the browser wars back in the beginning was to essentially was by doing monopolistic practices, which of course everybody knows that they were sort of famous for back in that time. They would bundle Internet Explorer with the operating system. Everybody used Windows. Like Mac 10 was not out, so you couldn't. Mac 10 didn't have preemptive multitasking. It was a beautiful but terrible operating system, and so every programmer used Windows or Linux or Unix. Most people that had desktop were Windows,
Sorry to interrupt. They even made it the browser integrated like the finder, like what we call the finder window. They had the file manager, and so everything operated like a web page. And so like you would literally be in the middle of browsing your files and like, oh, I need to look something up, and you just type a URL in your file window, and it'll take you to the web.
Yeah. They were definitely utilizing the operating system dominance they had to push the browser and to push their web server. So their web server, which was called IIS, still is called IIS, they would do things. And so like my original team that I worked on a number of teams because I was a build and release engineer. So I could work across multiple teams. One of them was the web server team. Later on, I took on the JavaScript, like the standalone JavaScript project as the release engineer. But IIS was bundled with Windows. You could download Netscape web server, called Netscape Enterprise Server at the time. And but Microsoft kept doing things like they had their servers they had Workstation and they had server, and Workstation was cheap and server was super expensive. And you could easily run Netscape. IIS was bundled on server and not Workstation. You couldn't get IIS on Workstation, but you could easily run Netscape Enterprise Server on Workstation. So then Microsoft basically hobbled its TCP/IP stack to not allow more than 5 concurrent incoming connections on Workstation. Hobbled the entire operating system to basically cripple Netscape. That was basically the point at which Netscape fought back legally, and that was the beginning of the antitrust, like successful antitrust suit against Microsoft that ultimately forced them to bundle multiple browsers and to do things like that. So this was a huge time in the history of the web. It was a time where, right now, people who weren't around back then or don't remember it that much, these days, a lot of people might look at Bill Gates and think of him as a great guy because he's doing this fantastic philanthropy. And I am one of those. I think the stuff he's doing is great, especially the microchips that are going into everybody. But back in the day, he was considered a very, very bad guy by a lot of people for doing this type of stuff. So anyway, some interesting history. This read write fail. This is to the point of something that Laser was saying. For years into the mid-aughts, this group TC39 was trying to rewrite the spec in a way that was not backwards compatible, and spent probably half a decade trying to adopt EC3 or EC4, I think it was. That was the ECMAScript 4 was the big push that was non-backwards compatible, and it just completely failed. And now evolutions to JavaScript and ECMAScript have all this legacy that will just be there forever. All right, moving on. So that's some of the history. There's a lot more. There's some interesting stuff. You can go and read those papers or watch those videos or share any tidbits that you guys know about here. But let's talk a little bit about the language, JavaScript, the language. So the first thing we need to note is that the world's foremost expert on concurrency in the JavaScript programming language is the organizer of this talk right here, one Aaron Swenson-Healy, who wrote a blog post called JavaScript Event Loop Explained, which is it's at least top 3 all-time views of Carbon 5 blog posts. And it was written 8 years ago, and it still gets traffic. And I mean, with the face like that guy, how could it not? So I always think that talking about the concurrency model in a programming language, especially one like JavaScript that has a pretty decent concurrency model, is interesting. And JavaScript is a sort of unique one in that it uses an event loop. And I'll go over it quickly because I bet a lot of people already are well aware of this. But the idea of an event loop is that it's like a game loop. If anybody's ever done game programming, there's a thing that just keeps cycling, and whatever actions need to be handled on the next tick or the next loop of the event loop, they get handled. And so basically the language is there to, you can execute stuff synchronously, which blocks the entire runtime of JavaScript. And then if you want to do something, if you want to free up the processor to work on somebody else's code for a minute, you put something onto the stack of events that are going to be processed by the event loop. And that happens through language features. Like, it's not like you're adding something to a stack manually. But if you're going to do something that requires input output, doesn't require the CPU, you essentially tell the runtime that you want to do that, and then you tell it, okay, and when you're done, here's what to do next. And so that is how it's a very good, it's a highly performant concurrency model. You don't have threads. Threads under the hood, but you don't have to worry about threads or actors or things like that, which can be confusing conceptually. What it gave us was callbacks, and I'll talk about that in a little bit. And callbacks, while they're extremely conceptually easy to understand, do this thing and then do this other thing, no problem, right? They're ugly in code. And so there's some things that have happened, which I'll talk about. But I would strongly suggest that people who haven't read this blog post read it. It's totally relevant to this day. And plus is making Aaron blush. That is like the best possible thing. Okay, let's talk about the basics of what JavaScript looks like. I'm going to go through this stuff fast because, again, I know that everybody knows this. JavaScript looks a lot like Java. Let's just be honest. That's what it was designed to look like. And by looking a lot like Java, it means it looks a lot like C. You've got blocks that are encapsulated with curly braces. You've got parameters, functions and parameters with parentheses. It's declarative. It is also functional, but it looks mostly declarative. It looks a little bit like this. You have try catch. High level, it looks like C. It looks like Java. It does have an interesting component. It's a prototypal language. It's not an object-oriented language. Now there are language features to make it more object-oriented seeming. And the deal there is, I'll talk about what prototypes are, but using the concept of prototypes, it's not that hard to basically create an object-oriented language or an object-oriented looking language. So a number of people back when this was all brand new thought prototypes were great. They were more flexible than OO. The reason, another fun fact, the reason JavaScript uses prototypes and doesn't use objects, at least initially didn't have first-class objects, is that Sun said no. Sun said Java is the object-oriented language that's in the browser. JavaScript is supposed to be a sidekick. You don't get it. Objects are for Java. And so that is why. So let me talk a little bit about prototypes. So a prototype, every object or every object in JavaScript has a prototype chain. And so every object has a property called prototype that gives you the prototype for that language. And then there's a chain all the way up to the root. So there's a root object that has a prototype of null, and that's where it ends. And just like an object-oriented programming language where you extend one object, extends another, extends another, extends another. There's a prototype chain here. And as you can see here, when you ask for a property of an object, it pulls it off of that object. And if it's not there, it steps up the prototype chain, and that gets repeated up until there's no more prototype. And then if that property isn't there, then that property isn't there. But it's like overriding in a way. But you don't declare classes. You can set this prototype chain up at runtime. There's some default. So by default, every object you create has a prototype, but you could change that. So right here, we create this object or this function f that has two properties, A and B, create a new version of that, call it O, and then we can set some properties on the prototype of that. If you say O.A, you'll get 1. If you say O.B, you'll get 2. You won't get 3. As you can see, it pulls B off of itself before it goes to the prototype. It was already there on itself, so it doesn't get the prototype's B, which is 3, but O.C will be 4 because it doesn't exist on the object, so it goes up the chain. JavaScript also has this built-in method on the default prototype. I think it's called object, called hasOwnProperty, and it's how you can see, like, do I have a property C, or is that maybe, if I check for the existence of O.C, that doesn't tell me whether it's mine or whether it's up the prototype chain. So there's a way to identify that. These prototypes are like, it could be confused. It's confusing in a way because a lot of people are used to object-oriented programming. This is similar, but not exactly the same. And so it can be confusing in that way. And that was one of the reasons that newer versions of JavaScript syntax have included like the class reserved word and things along those lines. Another, so since JavaScript doesn't have object-oriented programming, and you don't define classes in the same way you do in Java, how do you encapsulate data? How do you scope your data in JavaScript? And the answer to that is closures. And the idea of a closure is if you have a function and that function has access to scope outside of itself, and you can pass that function around, that function will retain access to the scoped data around it as it gets passed around. And how that's, Aaron, go ahead.
Oh, I was going to ask, like, was JavaScript the first language that most, at that time, like, were there really any other languages that had closures? Did Java have closures at that point?
I don't think Java had closures at that point. And I'm not, closures are more a standard library add-on in Java, I think, rather than a sort of core language feature, if I'm understanding correctly, or if I'm remembering correctly. You may all remember that I haven't programmed in a long time. So no, I mean, not that I know of. The languages that I used back in that time were like shell scripting languages, Perl, JavaScript, and a little bit of C, and they all, none of them had closures the way that JavaScript has closures still. So the answer is I don't really know. But so under the covers, if I'm remembering correctly, what happens is, like, scoped variables exist on like the stack typically, and in the heap maybe when you're at any point of execution in the program. And when a function gets returned from another function, it's scoped, the data it has scoped to it, but outside itself, that it has access to, gets copied onto the heap into a place that it has access to. Now, I don't know all the details. It might work differently in different implementations of JavaScript, but nonetheless, if you look at this function called curried adder. The idea here behind curried adder is you can pass a number and it will give you back a function that will add that to whatever number you pass in later. And so it defines a function here called f, and that function takes m, and the return value of that function adds your original n to that m. That function that we've just created, that adder with a sort of hard-coded addend, one of them, is the function itself is returned from this function curried adder. So if I create a variable called add5 and I assign it the value of curried adder given the value of 5, what I get is a function that will add 5 to whatever I tell it to. So if I call add5 and hand it 10, I get 15. Now that isn't that hard to understand. It makes sense. But if you'll notice, so I should have line numbers here. If you look at line const add5 equals curry adder 5, that 5 that I pass in is scoped to within those parentheses, right? It goes up and it's then scoped again inside the function curried adder. But by the time that line is over, that 5 is out of scope. It's not stored anywhere. I mean, explicitly. So how do I still have access to it when I execute add5 and pass it 10? That's because that function is, I don't remember how to say this. That function is closed over the curried adder scope. I'll be honest, like this closures is confusing to me. I mean, I get it in a simple version, but like using closures in large JavaScript databases is confusing because you have access to information, you have access to data that is nowhere lexically close to where you're executing the stuff, which is very different from object-oriented programming, where you can track back pretty easily to the part of the code base that you and see what your scope is. Anyway, it's powerful, and it's also it can be one of those things where you're like, what I don't understand what I have access to in my scope right now. Of course, debuggers help a lot. All right, moving on. See if I can move through this stuff a little faster. Callbacks. I mentioned callbacks. Callbacks are how you put functions onto the event loop. So you can see here, client.getFoo. Well, that is clearly an HTTP or REST call. So that's input output, which means some time is going to happen. I don't need the CPU, but when it comes back, I want to do something. So we put that anonymous function there as the second argument as the callback. Well, that function gets thrown onto the event loop stack and gets executed when the event loop goes around enough times such that the client.get is finished. This is how concurrent, multi-threaded or concurrent code is written, and it's not that pretty according to the general public. So, here's another way that you can do callbacks. You don't have to make them anonymous functions. You can make them first-class functions. It looks a little bit different, but it's, and it looks better, but it's still not what a lot of people, especially people who are used to writing more declarative code, are used to. Promises was the next thing to try and address this. You could define these things that return promises, and you could chain them together. And so you had to define your action somewhere else, but then you could get it. These are typically chained vertically. I ran out of space. I'm a horizontal coding guy. Everybody hates it except me. And you could, like, once you had all your sort of functions that return promises built, and I'm looking at this now. I think I did this fine. I did this wrong. There's this foo handler should not be taking bar handler. That should be out. But anyway, live coding. I'll do that next time. You can have what looks like sort of nice declarative programming structure when you're doing your promise chain, but it's still not what everybody wanted. So finally, we went too far. we have nowadays async and await syntax, which is interesting because the thing I find really interesting about async await is it's syntactic sugar on top of promises. Promises are a core language feature. They look like a standard library feature. I mean, there's a promise object that, it could fairly easily be like a standard library thing instead of a core syntax thing. So to me, it always looked weird to have the async and await, which is very clearly a core language syntax feature, be syntactic sugar on something that looked like a standard library object, but promises are not a standard library object. They're in the core language. So anyway, the way async and await work is, first of all, you have to tell the computer that you're going to be writing some code in the async world. That's why you've got this like async block right here. The reason you have to do that, because otherwise it wouldn't be backwards compatible. You can't just start throwing await around and then have old versions of JavaScript runtimes know what you're talking about. So you have to wrap it in async. This is one of these hoops that JavaScript has to jump through. But once you're inside an async block, you can basically just say, instead of passing a callback or getting a promise, you can just say await, like on that third line there, and then it will automatically wait until the thing is done, resolve the promise to get you the thing you want, and throw the error if it was rejected instead of resolved. Now, I put try catch in here so it would look like the first thing we did and you could see it. But for those of you following closely along at home, you might realize that you don't need that at all, because both client.getFoo and client.postBar will throw E. And so catching it and throwing it again is not really, it's useless. So you can make this even prettier. And that's what modern JavaScript looks like, as far as I know. Again, I'm somewhat far away from modern programming these days. All right. The last bit of mine before I hand it over to the participants on the chat here is ecosystem. Any questions so far on language stuff? This was just high level. There's lots more there. I'm going to quickly run through the ecosystem. So JavaScript, like a number of other programming languages, has a number of different competing engines. The most popular engine that executes JavaScript is called V8. It's maintained by Google. It's the JavaScript engine inside Chrome and any Chromium browsers. It's the JavaScript engine inside Node and Dino for people who are familiar with Dino. Apple has its own JavaScript engine called JavaScript Core. Used to be called something else. I can't remember. It had a cooler name. But that's what's executing inside WebKit and Safari and anything WebKit. And then Mozilla still has SpiderMonkey. Of course, it's vastly newer and better than the original SpiderMonkey, but still codenamed SpiderMonkey, and that's what's running inside Firefox. There's a ton more, but these are, with Edge being a Chrome browser, Opera might have its own, or Opera is maybe, I can't remember. But anyway, these are, I think, the three kind of core ones. Now the engine is a little bit different from a runtime. A runtime is the thing that sits outside the engine that sort of gives you a way to execute your JavaScript. And so Node is the most popular server-side runtime, and it uses the V8 engine under the hood. Dino is a newer kind of a semi-drop-in replacement to Node that natively handles TypeScript and is built to be have more safety features, like not allow you as a programmer to do unsafe things, reading in from the file system in certain ways, encoding, decoding, stuff like that. And then obviously every browser is a JavaScript runtime. Every browser that supports JavaScript, which I guess is all of them, is a JavaScript runtime. And they use, as we saw on the previous slide, they use different engines under the hood. There still is a big notion these days of transpiling or real-time compiling different languages into JavaScript. Some of the big ones out there, obviously, are TypeScript. We're big fans of that at Carbon 5. That's a project that Microsoft owns. CoffeeScript, which was built by an independent person, used heavily in the Rails world, not that popular anymore, was another big one. And then Dart is another engine that Google maintains. That's sort of like a So Dart is the language that goes along with Flutter, which is sort of a cross compilation to native mobile framework. But Dart basically looks a lot like JavaScript, and I think can compile down into JavaScript and other languages, if I'm understanding Dart correctly. JavaScript, like other popular language, has a dependency management ecosystem. NPM is the root of that. Aaron will talk about one of the fantastic fiascos shortly. NPM was independent. There were a number of this leftpad fiasco that we'll talk about in a minute, and a number of other things I think caused and NPM would go down, and GitHub wound up buying it. It was a bit controversial, and GitHub is now owned by Microsoft. Do we want Microsoft to own all of the libraries that exist in, you know, the Node ecosystem and now the browser ecosystem too? Seems like it's working out okay right now. NPM is also a tool that you can use for module and dependency management. Yarn is a drop-in replacement, sort of, not quite, but is a replacement for NPM that still uses the npmjs.org dependency repository. Java has its Maven central repository. Different languages have their own place where dependencies are stored, and NPM is that for JavaScript. And then JavaScript is interesting because you could consider it a fairly lightweight language from a syntax standpoint. You know, you might put it in the same category as Ruby or Python when you're talking about how, you know, what your team makeup is. But it packs a heavy punch when it comes to performance in a number of ways. V8 is one of them. V8, as I mentioned before, is maintained by Google. It's the main JavaScript engine that runs Chrome and Node and a lot of things. Google makes V8 very fast, and they do that by having an army of really fantastic engineers working on it. That's how programming runtimes run fast. There's also another really interesting project that probably people are aware of used to be called ASM. Now it's called WASM or WebAssembly. And it's essentially it's a strict subset of JavaScript syntax. It's most of JavaScript. It's like it misses a few things. So you can essentially write JavaScript, but because they've pulled out some of the trickier, harder to performantize bits, you can make this run extremely fast. And that's why it's called assembly. It can run it can get down to like that level of performance, or at least from a branding perspective. But this is how, and now browsers natively support WebAssembly. They have, runtimes for WebAssembly that are different than their JavaScript engines because they don't have to support the trickier pieces of the syntax. And so if you see like what things that look like semi-modern video games running in the browser, you're like, how can it be this fast? This is because of WebAssembly. So that's a really interesting project. And so those are the two things I had here. There's probably more interesting stuff around JavaScript performance. Cool. That is most of what I had. That's pretty much the topics that I had. I have added one last section here called Fun Facts, which is going to be for some other people to talk about that I asked for. So before I jump into Fun Facts, any questions? Yeah, everybody was just waiting for Fun Facts. I get it. I had some fun facts. I just didn't have them in the Fun Facts section. Because they were like really fun. I would have had to call it really fun facts. And I don't know. Didn't want to do that. Sid, are you here?
Here, but I don't have anything prepared.
Well, you do. There it is.
Oh, snap. You got the slide.
Tell us about JSFuck.
Sure. Yeah, I'll be brief. Because of how casting works and how awful the truth table and comparisons are in JavaScript, which is why we use triple equals instead of double equals. Anyways, you can basically get any value you want out of using these 6 symbols. You can see this table here on the left is the value you want, and on the right is how to get it. So false is easy. You just do not an empty array, and wow, you have the false. True is the opposite of that. Undefined is when you try to access a non-element value inside of an array. NaN 0, 1. You can see things get a little bit more involved. And then, yeah, A is easy because you're getting the first element outside of a NaN because the first element of the NaN string is A. B is a little bit more involved. I don't actually know how that is being gotten, but that's how you get a B out. X is that tiny set of symbols down there. And then the screenshot of my terminal there is how you do in a browser alerts, oh God, why? And then you get an alert that says, oh God, why? Okay, that's it. Back to you, Mike.
Thank you, Sid. That was great. I thought after you got past B and you were just going to say, and X is obviously self-explanatory, but the rest of them I needed to explain.
Yeah, the X is the proof is left to the reader.
Piece of cake. Submit your responses by end of day. Okay, who's next up on the fun fact tour? Oh, it's Mitch. There you are, Mitch. I got your slide too, so I'm going to go to that.
Thanks much. There's a talk called WAT. It is all of 4 minutes long, and so it was a bit of a challenge to condense it down from its deep dive into curious Ruby and JavaScript edge cases. But this is the JavaScript subset of going into like increasingly counterintuitive things that the same sort of squirrely typecasting that Sydney just alluded to will lead you to experience if you go in entirely the wrongmost direction. So like empty array plus empty array obviously gives you an empty array, which prints out as an empty string. Empty array combined with plus an object will give you an object, sure. But since addition is commutative, you should be able to do object plus empty array, which obviously gives you the same result, which is 0. Object plus object will give you not a number, which is the one sequence in here which kind of makes sense. An array of 16 elements, each of them with nothing in them, is represented by a sequence of 15 commas, because sure. And if you join them on WAT, then you get WAT chained together like that. If you do WAT plus 1 as your join, then of course it'll concatenate the string WAT with the string version of 1. But if you do WAT minus 1, then the exercise would have been left to a reader, but the evaluation winds up being that WAT minus 1 string minus a digit will give you a result which perhaps accurately is not a number. So the result is Batman.
Nice. I will also add one thing to this WAT talk. If it's the same one that I watched, which it probably is, unless mine was like some sort of copy, basically Gary would show one of these things up on a slide and then click to the next slide, and there would be a funny like cat picture, and it would just say, and then he would just say, "What?" And then he just did that for 4 minutes, and it was really popular. I mean, it was a really popular talk. So that was a good one. Cool. Thanks, Mitch. All right. What's next? Oh, you can't really. Oh, same picture. We get the laser beam back. He's going to talk to us about leftpad, which you'll notice. Let me just go back a couple. WAT, JSFOC, where are they? They're in the middle. Where's leftpad?
Oh, Mike, would you hit refresh on your browser?
Oh, yeah. Please hold.
Oh, man, I ruined everything.
Not everything, just most of the things. Hold on. Trying to do this here. Reload. reload / please hold. My bad. I saw it in there and I thought I had the latest. Ooh, yeah, look at this.
Okay. It wasn't different enough to warrant crashing your web browser, but I mean, I guess you can be the guy. You can be the judge.
Share again, and let me.
Yes.
Oh wait, not that one. That small screen. Okay.
Oh yeah. All right. So leftpad. Y'all use npm all the time. The Node package manager. It came out, I think, about a year after Ryan Dahl released Node, and it was great. Like you didn't really have a package manager for browser JavaScript programming, so this was kind of revolutionary. But there were some problems with it, and one of the problems I think is demonstrated through the leftpad fiasco that Mike alluded to earlier, which started with this dude Azer. He's right there. He likes shredding it on his BMX bike. But he wrote a bunch of JavaScript libraries, and one of them was called Kick. Some company got a hold of him. His lawyers got a hold of him and said, hey, we've got a company called Kick. We want you to change the name of your Node module to something else. And he said, fuck you and power to the people. And understandably, like NPM, bowed under pressure. I think Kick also threatened NPM with some legal action if they didn't allow them to take control of the Kick name. So anyways, so power to the people and fuck you didn't win, and the corporations won. So Azer got mad, and as a giant like middle finger to NPM, he unpublished all of his libraries, all of his modules from NPM. One of them was leftpad, which is a library. I think it was like under 20 lines, and all it did was like add white space or leading zeros to strings. But evidently that software was too complicated for anybody to write themselves. So a bajillion different projects imported that. And when he unpublished it, those projects wouldn't build. So within 10 minutes, some dude who I think is associated with NPM wrote like a busted replacement for leftpad, which got some of the projects building, but not many of the projects. NPM, in a panic, restores leftpad from like a backup, and then everything works again. But in the end of the day, Azer no longer uses NPM. You can read about it on his blog. And NPM no longer allows you to yank or unpublish your modules from public consumption, unless there's some like caveats or whatever. But this was a huge fiasco, and it made everybody go, JavaScript, like we knew you were a joker community, and now we've got further evidence that you guys are a bunch of jokers.
Yeah, this was fun. This was a fun one. Everything broke because as you know, these dependencies are what do you call it? They're transitive. Thank you. So like what happened was about a bunch, but not an enormous amount of people use leftpad, but then, it bubbled its way up into Rails or whatever, some crazy stuff. And so everybody just broke. It was super fun. And then of course there was lots of so much I knew this was going to happen. There was a lot of sort of after the fact quarterbacks. It was pretty neat. Okay. Last slide I have. Oh yeah, I was going to add some more here, but then I ran out of time. Anyway, I'll share this deck for anybody who wants it. There's a couple links up above in the other slides about places to go see those, read about the first 20 years of JavaScript, a link to Aaron's blog post, although Googling Carbon 5 event loop is a way to do it. Aaron, you want to talk about this book, JavaScript, The Good Parts? And then Stefano, I'll call on you.
Yeah, it was a pretty influential book in my career. I think prior to that point, there weren't too many people in my life that knew how to write JavaScript, in spite of the fact that ES3 was out. It was a goofy language, and Crockford talked about certain parts of the goofy language that weren't so goofy that you could use to build like real stuff. And as someone else on this thread mentioned, like YUI or UI came out of Crockford and Yahoo, and I think that was kind of the beginning of when like the Web 2.0 stuff like kind of took off and started to separate from the like Web 1.5 progressive enhancement kind of style of building web apps. So read the book. It's only like 80 pages because there weren't a lot of good parts.
Stefano, you're up.
Oops, got on mute. So yeah, something I remember reading a couple years ago is that JavaScript, well, V8 at least, defines null, undefined, true, and false all on the heap. And it does so using a header file called oddball, because these are all oddballs that they are defined on a heap as opposed to a stack. And so that combined with like the propensity to put closure variables on the heap means that JavaScript makes much more use of the heap than a lot of other programming languages.
Nice. I like that. Good fun fact. Sorry I didn't get you a slide. I saw your thing. I wasn't sure you wanted a whole slide. And then if you responded while we were going, I had too much going on to like slide create.
That's all good. Here's a link to Oddball.
Anybody else have any last minute, just in time fun facts? Alex.
I slacked you a slide.
Oh,
an image.
Okay. Well.
Yeah, bring up your Slack while we're all
I
looking
don't
at your
know.
computer.
That's too. Can you show it on your computer?
Yeah, if you can give it to me, then I can do it.
Hold on, let me stop my share. How do I already stopped my share.
Yeah, it's because it's like this little tiny image, but yeah, I can't just post it in the chat and Zoom, unfortunately.
I think you have it now.
You are now the host, Alex. You can share your screen. Make sure you close Slack first.
That's what I need to show. No, I'm trying to get the right window, but I don't think I can do it. Oh, here it is. Yeah, can you see that?
Remove unnecessary files from Git.
Yeah, this is a screenshot I took. And so this is a mistake I made. Well, actually, we had a sub project in our project. And this is a node server. It does nothing but allows you to save a file. It includes, I think package.json has a single dependency, which is Express, and maybe one other. And so at any rate, I created a PR. I checked in node modules. And so this is the PR of me fixing that mistake. It's a 1 million line PR. I moved 1 million lines, which just kind of shows you the state of JavaScript these days, that there are so many dependencies. I mean, even the package lock files are like 50K. So, I mean, 50,000 lines. So, and this is for like really tiny projects. So, I mean, and I think anyone who like starts a new project, like it's nice that NPM shows you all the, all the security issues, but you can start a project and have like 50 security issues. It's kind of just like a messed up situation. Everything's a little bit too dependent on everything else. And yeah, and you like, whenever you import something, you're probably going to end up importing another 50 packages and you just don't know what's in there. One of those could be the next leftpad. That's cool. I got rid of a ton of code in this PR.
This is like my favorite PR I've ever seen, minus 1 million lines.
Did they like check in their node modules or something?
That's what I did. It was me.
Gotcha. Got it.
Fun sort of fact, Yarn 2, new version of Yarn, checking in your node modules is apparently their preferred way to do things. And I was going to upgrade for stickies and I was like, nah, I'm not doing it. I mean, I get it. They have reasons. Their reasons are not bad. The reasons are reproducibility, and they make sense. And I'm still not doing it. All right, we're a little past time, I think 5 minutes, but if anybody has any last fun facts, I'm sure everybody here would like to hear it. All right. Well, Aaron, before we go,
Yes.
do I still get, are we still doing hats?
Oh yeah. I just need your mailing address, and you'll receive a Raver bucket hat from the mid-90s.
All right.
Perfect. Thanks for the presentation. It was rad. And thank you all for coming and continuing to support the really great Carbon 5 Languages get together. See you in 3 weeks.